there's a relationship between the average number of cavities developed in each of his patients' mouths per year, that's the Y, and the number of minutes they brush their teeth each morning and evening, that's the X. Ben believes that the function is Y equals 2 over X. Okay, so let's write out what these are. First of all, write down what Y represents, and then write down what your X represents. So in this case, Y is the number of minutes. And X is, let's see, hold on, I think I got that backwards. Number of cavities is Y, my bad. So this is number of cavities. And then X is the number of minutes that you spend brushing during the morning and the night. Okay, and then the relationship is Y equals 2 over X. So basically, if you take the number of cavities per year and you multiply it by the number of minutes that you spend brushing, what are you going to get? What would that always equal? What? Yeah, I can give you an hour. I think you're in the wrong planet. What? Okay, if Y... I'm looking at the wrong problem. Yeah. Okay, yeah. You see. That's why you're off of the chat monitoring. Holy cats. All right. This is what the guy says. If I wrote this as a multiplication problem, that's the same as X times Y equals 2. Those are the exact same thing. So if we were graphing this, every point on this graph, no matter where we picked, if we took the X and the Y coordinates and we multiplied them, we'd always get 2. So there's a relationship between how many minutes you spend brushing times the number of yearly cavities. Okay, and this dentist said that those would always multiply together to be 2. All right, so the second part's asking, well, how many cavities? All right, that's our relationship. If she brushes her teeth 2 minutes in the morning and 2 minutes in the night. So where am I going to place that 2 minutes in the morning, 2 minutes in the night figure? For X or Y? Yeah, so all I'm going to do now, because this is telling me it's not 4 minutes, it's just 2 each morning and night. So you don't have to put 4 in there. It would just stay as 2. So all I'm going to do is just let X equal 2 minutes. Substitute it in, and this person on average should have 1 cavity per year. Pretty simple. All right, Shamsi, what kind of name is that? Shamaz? Shams? Shams? I don't know how to say that. Okay. Develops 4 cavities in a year. Find the number of minutes she likely spent brushing her teeth each morning and night. So again, I just take my relationship here, and now I'm going to let y equal 4, because that's our cavities, and I'm going to solve it for x. One half, and what is the unit? Okay, so you have cavities. If you solved for x, x is minutes, right? So she spent 30 seconds brushing her teeth each morning and night, got more cavities. Pretty simple, straightforward. All right, now the stuff that we're doing next is we're going to be using a graph and algebra to solve questions. All right, so the next one here. Okay, you have a stringed instrument like a violin. Okay, the length of the string is L, is represented by L. Okay, so I guess we can put it right here. So L is the length of a string length. Okay, and V is the frequency of the vibration. So this is the frequency. And that's in hertz, H-E-R-T-Z. All right, so that's just basically how fast is this thing when I pluck it, how fast is it vibrating? What's its frequency, or what's the frequency that it's vibrating at? All right, and then we're given this function here. V is 1,000 over L. So basically, this would be the same as saying, if you take the frequency, if I take V and I multiply it by L, I always get 1,000. These two things are the same. That equation and that equation are the same, just written differently. All right, it says use technology to sketch the function for L equals 0 to 20. Okay, now what does that mean? L is 0 to 20. What's that telling you about the string? Yeah, it can only go up to what? 20. Okay, now that's L. So L is represented in centimeters. So this graph is going to give us a graph for strings that are 20 centimeters or shorter. That's all this means. All right, so when we set this thing up, okay, if I look at this formula here, V, and this is the important part so you know where to put your labels, L, okay, what axis is the L and what axis is the V? Right, so LV. So down here, L is centimeters. So this is the critical part of making your drawing here, is that you put what each one of these are. So the part that keeps confusing folks on this problem is this little deal here. Basically, we're just going to look at strings that are 20 centimeters or shorter. Okay, and now here, this is V, so this is the frequency of the vibrations. Frequency, vibrations, and that's in hertz. right? Now what we're going to do is go ahead and graph this thing and take a look at the drawing. Okay, so when we set this thing up, graphed, right? Okay, now when you go to draw this thing, okay, so if you just look up here, guys, it looks like this, and I want to try to get it as accurate as I can. All right, to that. But I'm kind of just sketching it, so I've got to figure, does it really hug the corner? Does it not hug the corner? Okay, so here's how you can do that. You know that down here, what are you counting by? Fives, yeah, so that's 5, 10, etc. Okay, and then over here, we're counting by hundreds, right? Okay, so I know that no matter which two numbers I pick, when I multiply them, I'm going to get 1,000. So if I was at 5, what would the y coordinate be? Yeah, 200. So that kind of gives, if I plot that, 5, 200, that kind of gives me a better idea how close to draw my graph to the corner. Okay, so if you really just need about 1, and it just tells you how tight your graph is to the corner. And then the rest of it can just be a sketch. And I would turn in this graph. This graph tells the person, me, how all the information I know, or that is necessary for me to know that shows you understand what you're doing. Okay. Now, to get fancy, you could type this into your calculator. It just takes a whole bunch of time. All that's going to do, guys, is it's going to make your graph stop at 20. So your graph's going to go 5, 10, 15, 20, and it's not going to go any further. Okay, that's all that does. Okay, so it's not really necessary to type in, but it's always a good thing to know. So I'll show you how to put it in. Go back to your y equals. Okay, we want to only graph this for values up to 20 and no more. Okay, so what you're going to do is go to the end here and put in a parenthesis. Okay, and then you're going to type 0, 0. Let's see, I think these new calculators, we don't have to break it up. Let me see. I'm going to go second test, and that's where I find my less than, enter, X. Okay, now don't do this part. I want to see if this works. Second test, less than or equal to, they might have fixed this, hold on. Second test, less than or, it used to have to break this up into 2 statements. 20, close the parentheses, see if that'll graph it. Oh, it does, it works. Okay, so this graph, if I zoomed out a little bit on this, it would stop, it wouldn't go past 20. My window go? Let me just check one other thing here. X. Now I'm going to do it this way. This is how we did it before. Change this to the word and then we did X less than or equal to 20. Close the parentheses. Okay, that should be the same thing. Fix my window, got all messed up. Max. I'm going to go a little bit farther just so I can see stop. So I'm going to make this 55, 0, 1,000. Okay, you see how it stopped right at 20. That's all that did. So typing in this part of the equation just makes the graph stop at 20. That's all. So that's how you input that. Okay. All right. Okay. So now what we want to do, are we okay on that part, guys? Anybody at home have a question on that? Let me know if anybody pops up in there, Mackenzie. Okay. So we've got that done. Now it says find the frequency of vibrations for a string that's 10 centimeters long. All right, so we just take our formula, and it's pretty simple problem solving. Okay. And dare I ask Tyler, where do we put the 10 centimeters?
It's 100.
Okay, where do I put it in this equation?
If it's not the L.
Then it's the V, right?
Of course. Wait.
You're okay.
No, I was right.
Yep, 100 hertz. Do you guys know what a hertz is, other than a car rental company?
Oh, it's hertz, don't it?
It's what? Go ahead, Brian. Ryan. For measuring sound.
Like sound waves?
Yes, I think it's something like that. Yeah. Let's see. What's a hertz? What is a hertz unit? Yeah, defined as 1 cycle per second. Okay, so depending on the length of that, it takes if it was a string, from one high point, like if you look over here at this drawing, from this high point to the next high point would be a second. Okay, that would be a hertz. So if something was like 500 hertz, that means within 1 second, it goes through 500 cycles. Okay, so it's vibrating pretty quick. All right. Now, draw the line L equals 5. Now, this is the part where you have to have your drawing labeled. All right. Because you're either, on these problems here, you're either drawing a horizontal line or you're drawing a vertical line. And the way that you tell is by the labels. Okay, L, that is 5 centimeters. Centimeters is on the x-axis. So we're going to draw a vertical line at 5 centimeters. Okay, so this is our x-axis. So this is telling us to draw a vertical line on the x-axis. Vertical line at x equals 5. And then it says, explain what it means in the context of this problem. All right, so if you go back to your calculator, all right, if I draw a line that's y equals 5, it's a horizontal line. Okay, I can't draw a line on this page that is x equals 5 because it's not a function. Get rid of this stuff, so error. So I can't do it right here. You can't draw vertical lines on this page. So if you look at the calculator here, okay, look, I'm pointing right at it. You'll see a little tiny word, it says draw. Okay, that's the menu you got to use to draw a vertical line. Okay, so to draw a vertical line on your calculator, you go second, draw, and you're going to go down to number 4, pick 4, and you're going to say, put a vertical line at 5, and hit graph. Okay, where's my vertical line? Let's try that again. Second, draw. Okay, 4, vertical line at 5. There it is. And now that's what your drawing looks like. Okay, so we add that to our picture here. Okay, so now we're going to have a vertical line right here. At x equals 5. So that's, or L equals 5. And that was that point that we picked earlier. The y coordinate with that would be 200. So what does this mean in the context of the problem? What's that telling you?
Have the higher the
Yeah,
frequency.
yeah. So a string of length 5, okay, has vibrates at a frequency of 200. So a 5-inch string, 5-inch string has a vibration frequency of 200. A frequency of 200 hertzes. So again, just to explain, the string's vibrating, doing that. For it to vibrate from here to there, it happens 200 times every second. That's what that's telling you. All right. All right, now answer this. What's the length of, add this to this problem here. A little extra. Okay, draw the line V equals 400. And what does it represent? Okay, so V is the horizontal axis, or the vertical axis is the Y axis. So you're going to draw the line, you're going to draw a horizontal line at Y equals 400. You can do that on your calculator real easy. Just go to Y equals and add 400. Y equals, go down 400 and graph it. Okay, so that's what it's going to look like. And what's the intersection of that and the curve represent? Okay, so that's this point right here. Get that one. That one was 5,200. And this one is, its Y coordinate is 400. What's its X coordinate? Yeah. Any questions on how to get that? How to get the 2.5? Okay, just dropping 400 in there, then solving that. 400L is 1,000, then divide by 400, you get 2.5. Okay, so what does that represent? Yep, so, yep, length of 2.5 centimeters vibrates at 400 hertz. Yep. Okay, last, can I move ahead? Any questions? Questions from the home crowd? Nope. Nope. All righty. So in order to figure out if you're doing a horizontal or vertical line, you got to have these things labeled. And that tells you whether you're drawing a horizontal or vertical line. All righty. Last one. Tack. Boy, they got some strange names in this. Chamois. That's shams. Okay. Tack. Tack's phone can store 64 videos that are 1 minute long. 32 videos, 2 minutes long, 16 videos, 4 minutes long, etc. What's the number of videos 16 minutes long can he store on his phone? So what you can do is just make like a table. Okay, so 64, I got 64 videos. We'll make this videos. And this will be the length. That's 1 minute. Right? 1 minute. Okay, and then 32 videos, 2 minutes. 16 videos, 4 minutes. So it's pretty easy to see a pattern here. Okay, and if I kept going, 8 videos, 24, 64, 8 minutes, 4 videos, 16 minutes, etc. All right, now the other day or yesterday we learned if you had a table, how can you tell that it can be modeled with a reciprocal function? So if you take these columns and you multiply them, you keep getting the same product. So 2 times 32, 64, 4 times 16, 64, 8 times 8, and so on. So that right there, okay, this right here, that tells you you can model this. We can model this using a reciprocal. Using y equals k over x. Okay, we can write that as a reciprocal function. Then we can graph it and do all that good stuff. All right, so we already solved A. 16 minutes is going to be 4 videos because we just did it on our chart there. Okay, now write a function that represents the relationship between the number of videos, x, and the length of time in the videos, y. So let's see, this is, the top is x, and this is y. All right, so how would I do that? Yep, so I know when I multiply these, I get 64. And now if I solve that for x, or for y, that's the same as y equals 64 over x. Okay, all right, now the important part here is getting the labels right. Okay, so this is the x-axis, which is the number of videos. So this is number videos. And this is the length in minutes. And when we do this, we'll just make these zeros. Okay, so let's type that in, take a look, see. is 64 divided by x. Okay, get rid of that. And we could just leave it 50. This 0 and 100. 10. There's our graph. Okay, so on our x-axis, we counted by 5s. And on our y-axis, we counted by 10s. And I know that y equals 64 divided by x. So now I want to figure out how close do I draw this to the corner. Okay, so let's say that I had 5. Well, if I put 5 in there, 64 divided by 5, 5, 14, oh, it's around 12. 12.8 if I want. So if this is 10, 12 is just a little above it. And that kind of, this thing's going to really hug the corner. Okay, that's the point, 5, 12.8. There's my graph. Try to want to make it as nice, smooth. All right, last question. He wants to store 48 videos. Plot an appropriate straight line. Okay, so is your line going to be horizontal or vertical? Yep. This is the x-axis. So I'm going to draw a vertical line at x equals 48. Line at x equals 48. Okay, if I did it on my calculator, that's when I used my draw menu. Okay, second, draw, vertical. Okay, and oops, did I type in 48? Second, draw, vertical. So you get the idea where it's going to be. Okay, so here I got 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. My vertical line is going to be just a little shy of that. Okay, that's x equals 48. And now we want to find what's that intersection. So 64 divided by 48. Divided by 48 is 1.3. Yep, 1.3 repeating. Okay, so that would be 1.33, and what's my label? Pardon me? No. Is it in minutes? Oh, yes, it is. I'm sorry. I apologize. 1.33 minutes. Okay, so the maximum length is 1.33 minutes. What's that in minutes and seconds? A minute and 27 seconds? 20 seconds. Okay, so I'm going to do 1 minute, and I want to find what 33.33 of 60 is. 0.33 of 60. Okay, 1 times 60, 20 seconds. So more accurate would be 1 minute, 20 seconds. Yeah. I don't know. You're probably right. Okay. They're equal. There you go. All righty. Okay, guys, you got your assignment done. All right, and tomorrow, so what we're going to be doing tomorrow is how to take these graphs, because we've been working with really simple graphs like, 6 over x. How do you graph it if you had something like 6 over x minus 7? Or 6 over 2x plus 1? Or 6 over 2x plus 1 plus 10? Tune in tomorrow, Cobra Kai.
Sure. Copy that. Sometimes you
I'm older than you, so therefore I have that term. I don't know.
maybe actually.
You guys are technically both copies.
Yeah. Oh, yeah. Yeah, that's right. Do you need time to kind of prepare some? Okay, I want to do it like Thursday. Are you able to stay after school or? Okay, let's plan on that. Okay, cool. Clear. Vertical. B. Calc. Intersect.
I want to see right there. The obligated. Forced. All right. I